Hello, welcome to today's lesson on section 9.4, which is titled Graph and Write Equations of Ellipses. So, if you're not sure, an ellipse is like an oval, and ovals can actually open horizontally or vertically, so meaning that the longest axis could be horizontal or vertical. We'll look at both. And we'll also take an in-depth look as to what an ellipse truly is. So as usual, we'll start with the Euclidean definition of an ellipse. An ellipse is the set of all points in which, and now we've got to be careful with the wording here, in which the sum of the distances from two fixed points is a constant. Let me actually draw a coordinate plane and an ellipse for you guys. So that right there is an ellipse. Now let's say I were to pick two fixed points. Here as well as here. And if I were to put a random point on the ellipse, measure that distance, measure that distance, call that D1, and call that D2, then D1 plus D2 will always equal a constant. If I were to pick any point on the ellipse, so on the green curve, and connect two segments, one to the first F point and one to the second F point, and add those two segments, it will always equal a constant. The two fixed points are called the foci, which is plural for focus. So that's kind of how an ellipse works, is that it's a set of all points in which the two distances that you connect from the point on the ellipse to two fixed points, the sum of those two distances will always be the same. Some other things I want to discuss with an ellipse. So here we have what I call the horizontal ellipse. And here is what I call a vertical ellipse. The longest axis we call major. The shortest axis we call minor. So in this case, this right here would have been my major axis. And then using turquoise, that right there will be called my minor axis. Notice how I use letters A and B in the first ellipse I drew. Those are going to be the endpoints of your axes. So 0, or actually, let me do this again. plus or minus a comma 0 will be the endpoints of the major axis. And they're also called your vertices. So here are your vertices. They're always the endpoints of the major axis. Using a different color, we'll call this negative b and b. 0, comma, plus or minus b will be the endpoints of your minor axis. So hopefully that helps. We save A for major and B for minor. You know, A is first in the alphabet, B is second in the alphabet. Now these will be called your co-vertices. So CV and CV. Let me actually write that out a little more neatly. Co-vertices. The length of the major axis will always be 2a. The length of the minor axis will always be 2b. So this length right here is 2b, and that length right there will be 2a. And lastly, F represents your foci, and those coordinates will be plus or minus c comma 0. So basically the distance from the center to either foci will always be c. And of course this is assuming your center, the assumption here, your center will always be at 0, 0. We'll look at how things will be when it's not 0, 0 when we get to 9.6. So the foci always on the major axis. And the distance from the center to either foci will always be c. Okay. So now let me kind of summarize all this because there's a lot of information I wrote. Here's the equation for an ellipse with the center at the origin. X squared over a squared plus y squared over b squared equals 1. This is when you have a major horizontal axis. The vertices are at plus or minus a comma 0. Co-vertices are 0 comma plus or minus b. And if we make another column, your foci will be at plus or minus c comma 0. Now, for a vertical ellipse, everything's just reversed. That's a, that's negative a, that's negative b, that's positive b, vertice, vertice, co-vertice, co-vertice. Major is this way, minor is that way, so it's all reversed. Your foci always be on the major axis, and that's c, and that's c. So now it's going to be x squared over b squared plus y squared over a squared equals 1. Vertical major axis, your vertices are now at 0 comma plus or minus a. Co-vertices plus or minus b comma 0, and your foci will be 0 comma plus or minus c. One other thing that we need to understand, or actually I need to let you know, we'll understand it later. This allows you to relate A, B, and C together. Why this is true, we will get into that when we come back from ski week. But for now, I'll just tell you that C squared equals A squared minus B squared. And of course, we assume A is greater than B, because A is part of the major, B is part of the minor. Okay, so it's a lot of information, but now I think we can do some examples. So number one, you're asked to graph 4x squared plus 25y squared equals 100. So step one, and this is on example 1, page 635, step one would be to write in standard form. So if you write in standard form, we want to divide everything by 100. Because standard form requires you have 1 on just the other side. Notice how both of these have 1 right here. So you get x squared over 25 plus y squared over 4 equals 1. Step 2 will be to identify A, B, and C. Well, since denominator below x squared is greater than the denominator below y squared, it's pretty obvious the major axis is going to be horizontal, according to what we stated up here. Because remember, A is always greater than B. So in this case, A squared equals 25, so A is 5. B squared equals 4, so B is going to be 2. That also means that C squared will equal A squared minus B squared, which will be 25 minus 4, 21. So C will equal root 21. With all that information, I'm actually going to scroll down because I need more space to graph this, but with all that information, we can now do step 3. So step 3, use A, B, and C to plot the vertices, co-vertices, and foci. And just to summarize, A equal 5, B equal 2, and C equal root 21. So make a coordinate plane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, changing colors, we'll go to red. Now we know the major axis is horizontal because A squared was beneath x squared. So I'm going to plot negative 5 and 5 here. And B will be 2, negative 2 on the y-axis. Root 21 is roughly 4 point something. So we'll put it in between 4 and 5 for the foci. So your ellipse will look something kind of like this. Here are your vertices, here are your co-vertices, and here are your foci. And if we summarize, your vertices will be plus or minus 5 comma 0. Your co-vertices will be 0 comma plus or minus 2. And your foci will be at plus or minus root 21 comma 0. There's actually a few more things we could say about the ellipse, but I'll kind of save that for when we get back from ski week, like, maybe talking about length of the major axes, the area, another thing called eccentricity, which I'm not going to get into today. But that basically shows you how you can graph it. We'll see a couple more examples, then we'll be done. For number 2, this is example 2 on page 635. You're asked to write an equation. So step 1, make a graph. So if I make a quick graph, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And for some contrast, let's go black. So your vertex is at 0, 4. So it means you're also going to have another vertex at 0, negative 4, because the center is at 0, 0. Co-vertex negative 3, 0. So you're going to have another co-vertex at 3, 0. So it looks like this. So that means, so step 2 now, identify A and B and plug into the proper equation. So clearly A is going to equal 4 and B is going to equal 3. And that's actually a little bit off. I apologize. It should be like right there. And the proper equation, the major axis is vertical. So if we look at it, the major axis is vertical, we want to use this formula. So it'll be x squared over 9 plus y squared over 16 equals 1. Okay, one more example. Same steps. Make a quick graph. So you have vertex -8, 0. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it means you're going to have another vertex at 8, 0. Focus at 4, 0. So you're going to have another focus at -4, 0. But there's a problem. What about the covertex? See, we know that A is going to equal 8 and C is going to equal 4.
What's up? Yeah, I'm hoping that it's like 5 minutes.
But what about B? So if I use this formula, C squared equals A squared minus B squared, you get 4 squared equals 8 squared minus B squared. B squared should equal 64 minus 16. B squared will equal 48, or B will equal root 48. So that's roughly between 6 and 7. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. So your ellipse will look kind of something like this. So step 2, the major axis is horizontal. So we want to use x squared over a squared plus y squared over b squared equals 1. We already know what a squared is going to be. It's going to be 64. And b squared we now know is 48. And we have our answer for that one. So we're all done with the video. Sorry it was a little long, but ellipses do take a while to explain. We'll do some practices with this during block number 2 this week. And then, of course, we'll keep talking about ellipses when we come back from ski week, because Friday is just going to be a fun day. Okay, we're all set. See you guys later. Bye.